Alright, today we will be going over special triangles and simple angle measurements. As you can see in this triangle over here, it's a 45, 45, 90 triangle. So, this triangle and the 60, 30, 90 triangle are all going to be what are called special triangles. So, essentially, what that means is these sides will always have the same ratio. So, for example, let's start with this one here, right? With the 45 45 triangle, both of these legs are going to have the same length, and this hypotenuse will always have the same length as the legs times the square root of 2. So, something to remember is just that 45 is half of 90, so just split the length between these two sides, and they're going to have to be even. So just think of it that way. These two angles are the same. These two sides are going to be the same. And this is the square root of 2. Since there's two of these, you just got to remember the square root part. Next up is this 30, 60, 90 triangle. This one's a little harder to remember, but think of this small angle. The 30 goes with the square root 3, and then the 60 goes with the whole A right here. So this 2a right here is going to be the hypotenuse, and there's not as easy of a mnemonic to remember that, but you'll just kind of have to commit this to memory. So right next to the 60 is the a, and right next to the 30 is the a times square root 3. Next is going to be these simple measurements here, which kind of look super weird to just look at from the start, but I promise it'll make more sense later. So, to start off, the sine of 30 is 1/2. So, basically, what that means is when you put in the sine of 30 into your calculator, this is the number you're going to get out. So, this is helpful if you have these said triangles and you're just trying to figure out um, either the hypotenuse or another side or something like that, and you don't remember this part, you can always just put these into the calculator and get the other side length that you want, or the angle, which we can go over in another video if you would like. This 45, both the sine and the cosine are going to have this 1 over square root 2. And all that means is that these two angles will be the same as they are right here, 45 and 45. That's why they're both the same. Now, this square root 3 over 2 is the larger of these numbers, right? So it goes 1 over square root 2, 1 over 2, and then this is the largest. So these will be inverted for the cosine. As you see, this 30 right here gives you the 1/2 for the sine, and the square root 3 over 2 for the cosine. So essentially, you're going to use these three numbers for both of the sine and the cosine, and then tangent's just special over here because it wants to be. But other than that, these are the three angles that you'll have to just commit to memory. There's no super easy way to just remember them, but yeah, these are the angles that you're going to need to remember. So sine of 30 is 1/2, sine of 45 and cosine of 45 is both 1 over square root 2, sine of 60 is going to be square root 3 over 2, and then just invert that to this cosine, square root 3 over 2, then 1 over square root 2, then 1 over 2. Tangent here is also special. You'll use these less often, especially as you get further into math. When you do what's called a unit circle, that you'll learn about later, you'll primarily use sine and cosine, but you'll use these as well. So they're important to remember. One of the things that's going to be very helpful to you is just to remember this tangent of 45 is 1. And as we talked about in another video, and you can see over here, it represents the opposite over the adjacent. and it compares these two side lengths. So as you can see here with this 45, these two lengths are the same as well as these angles, and that means that A over A is just going to be 1, which is how you get this value here. So that's just a useful tip to remember. If you remember this or this, you should be able to figure out the opposite way of reverse engineering it, kind of this special triangle. So yeah, those are going to be the special triangles that you need to know. And yeah, if you need any more help, just let me know, and I'll try my best to help you out.